Hello everyone, welcome back to our object-oriented programming tutorial series using MicroPython and the Raspberry Pi Pico. In the last episode, we just learned how to set up our Raspberry Pi Pico and turn on its internal light off and on and blink it a few times using our object-oriented process and the class called light. Today, as you can see on the screen, we are actually not going to work directly with hardware, and instead, we're going to work with a simulator. Now, the nice thing about a simulator is that you can set up your connections ahead of time, and even if you make a mistake, it's no big deal because there is nothing to burn up or anything like that. So it's a very easy way to get started. And there is this simulator that I really like called Wokwi. It is free to use. Of course, if you need more features, there is a fairly reasonable monthly pricing that you can sign up for. But for everything that we will do in this tutorial series, the free version works great. So what we will do today is we're going to set up a Raspberry Pi Pico simulator. We're going to connect a few lights or LEDs to our simulator, and we will use the same classes that we used last week and see how that works. And we'll go a little bit deeper into the object-orientedness of these videos. To create a new project, you go to the right top corner of your screen, click on My Project, and then select New Project. And go straight to Pi Pico. And although we are using the Pico W, it doesn't matter. You can use the regular Pico. And right here, you see that the Pico can be used with the Arduino C language or two different types of Python, MicroPython, which is what we were using in this series, or CircuitPython, which is another Python variant that you can use with the Raspberry Pi Pico. We will stick with MicroPython. Now, when you do that, you get a nice little empty screen. Let me get myself out of the way with the Raspberry Pi Pico right there. And that is your starter template. And you can actually run this thing. Of course, it doesn't do anything, but it actually tells you MicroPython version 124.1. Recall in the last video when we did and we ran, we saw MicroPython 125, I think, what was running on our hardware Pico. So in this software Pico, it is running MicroPython 124, which is fine. Most of the things that we would do works with basically all versions of MicroPython. Just like what we did last time, we are also going to upload the two Python files that we used last week. So we will go back to this Pico library. If you don't recall, I'll have a link to the MicroPython library as well as a link to the last video. We will need the lights.py and the log.py for today. So we'll upload those two, and you see that those two show up here. And just like we did last time, let's do the same thing that we did. And we are going to see right there is the LED. So what we're going to do is I'm going to run this. Yeah, it needs to be in run mode in order to do anything with it. So we'll say from lights import star, and then we will say my light equals light with the LED and built-in LED. And then we can say my light dot on, and you see the built-in LED turns on right there. And we can say my light dot off, and the built-in LED turns off. So just like we did last time, we can blink it a few times like we did last time. My light dot blink, and we have to say how long. So let's say half a second for 5 times, and you will see that the light blinks 5 times right there. So just like what we did last time, you can do exactly that same thing with the simulator. Now, the nice thing about a simulator, though, is that you can test out other hardware without having to physically connect anything. We are going to physically connect stuff, but we were going to leave that for the next session. Today, we're going to connect a few lights to our project. So let's make this a little smaller. I'm going to stop the simulation so we can mess with the simulation here. And you can turn this around. The easiest way to turn this around is the R key on your keyboard, and that basically flips the directions of the Pico. Now, what I like to do is kind of keep it in the same direction that I have it on my breadboard. So once we turn it around, I can start adding a few things to this simulation. So what we will do today, we're going to add, let's say, 3 different LEDs, and we're going to run it using some Python code. So let's take a look at adding these LEDs. And you basically just click on plus here, and then you can click on LED. And you do this, let's say we need 3 LEDs. 3 times, we got 3 LEDs here. And they look very similar to a hardware LED. We will see next week what a hardware LED looks like. If you have this kit, you will be able to see a lot of LEDs usually come with most of the kits. They're pretty cheap and they're very difficult to destroy. But we are going to be nice to these LEDs. We're going to, let's say, 3 different colors. What do you like? Red, green, and a blue. So we have 3 LEDs, 3 different colors. Now, one thing to remember that the different I/O pins of the Pico, when you turn them on, they supply about 5 volts in the output. Not exactly 5 volts, but let's say it gives you about 5 volts on the output. These LEDs, they run on between 1.5 to 2.5 volts, depending on what type of LED it is and how much current it draws. We don't need to worry too much about that. But obviously that means we can't just give this 5 volts that comes from the Pico output directly to these LEDs. That is going to cause some trouble. So what we do is we actually put something that reduces the voltage. And in electronics, the way you reduce voltage is using what is called a resistor. And the resistor comes in all kinds of values. What we will use is the typical value to use for LEDs is 220 ohms. And this simulator does a really good job. When you select a value, it color codes the resistor to exactly that color code that you would find in that resistor. Very similar to how we saw in the Pico, you can actually hit the R button to turn the resistor around if you need to. So since we want this kind of, we're going to try to be nice, keep things kind of neat. So we're going to line things up properly. And you can also do copy paste. So since this is a nice 220 ohm that I select it, I hit Control C or Command C to copy, and I can paste it a couple of times to get 2 more copies of it. So we will need 2 more for that. So again, the reason we are doing that is so that we don't supply the entire 5 volts to the LED. That could cause it to overheat and potentially damage it. Right? Now, the way LEDs work is that they have 2 pins. One is called a cathode, one is called an anode. Think about it as anode to be the positive pin and cathode to be the negative pin. Typically, you are going to supply your voltage to the positive pin and attach the negative pin to the ground. So the way we would connect this is, let's say we want to use these 3 pins, GPIO 3, 4, and 5. So we will put, click on 3, sort of run this and connect this to here. So that connects pin 3 to the resistor. And since this is the red LED, let's change. I don't like to use red wire for anything other than voltage, so we'll use the maroon color. All right, so then 4 is the green LED, so that can stay green. And then 5 is the blue LED. So we'll turn this one to blue. Okay, so now I've got the 3 output pins of the pickup connected to the one side of the 3 resistors. The other side, what we are going to do is take that to the anode. Same thing here, take that to the anode. Here, take that to the anode. And once again, if you want to change the color of the, I changed this guy too. And this one to blue. All right, so one side of our LED is connected. Again, so what we did, we took a wire, went from pin 3 to one end of the resistor. The other end of the resistor we connected to the anode, which looks like the longer pin of the LED. Same thing we did pin 4 to the resistor to the anode, and then pin 5 to the resistor to the anode. Now the other side is pretty easy. What we do is we take a ground bus, and we'll talk about ground buses when we go into the breadboard in the next video. But here, anything, you can actually connect to any of the ground pins as well. But today we'll just take directly from the anode pin, from the cathode pin to the ground bus. Actually, let's go the other way around. That way you get the black wire. Typically, when you have ground connections, you want to use black. That's a universally accepted color for ground. That's it. Now we are ready. So this is basically the connection. The cathode pins go to ground. The anode pins go to the IO pins via a resistor. All right, so we're ready. Let's just test out and make sure this works. So we're going to run again. Of course, nothing happens here because there is no code to actually turn these lights on, but we know how to turn them on. So let's say, again, we say from lights import star. We say red equals light. Red is connected to pin 3. So red LED. And now we can say red dot on. And there you go. You see the red light just came on. We can say red dot off. Red light went off. So just like we turned on and off the built-in LED, we can connect an external LED and turn them on and off just like that. Okay, so that's basically how we use the simulator. Now, we have been doing everything in code, so let's write a little bit of code to kind of run these in a sequence. How's that? We'll create an array with 3 LEDs in it, and we're going to run them in sequence. Okay, so let's say my LEDs equals, and in Python, you create an array using square brackets. And so we will say light 3 red LED. Then the next element will be light 4 green LED. And then the next one will be light 5 blue LED. So this creates an array containing these 3 lights. Okay. Now what we could do is we can forever while true, assuming that you already know a little bit of Python, but basically a while true is essentially an infinite loop. I want this to keep going forever. And what are we doing each time? We're basically going through for light in my LEDs. We will say light dot on. We will wait half a second. We'll say light dot off. So it's going to turn one light, then keep it on for a while, and then turn off the next light, and then keep doing that for all the LEDs. right? So that's our code. So simple, right? So let's save this as a project. So let's call it video 2. And we are going to run this. All right, so this is where we will start debugging some of the code. Of course, I missed something, and you can kind of see what I missed. It says name light isn't defined. Remember, before we can use the light, we had to do the import. Forgot to do the import here. So we will say from lights import star. Okay, so save that and run. And there you go. You get red, green, blue, red, green, blue, red, green, blue forever. So that's how simple it is to use object-oriented design to build little application using the objects. We will go more detail into what we did and what are the types of things that you could do with objects, but hope this was useful, and I will see you in another video. Thanks for watching.